Node selector is the simplest way to constrain pods to nodes with specific labels. Affinity and anti-affinity expands the types of constraints you can define. Some of the benefits of affinity and anti-affinity include: the affinity, anti-affinity language is more expressive. Node selector only selects nodes with all the specified labels. Affinity, anti-affinity gives you more control over the selection logic. You can indicate that a rule is soft or preferred, so that the scheduler still schedules the pod even if it can't find a matching node. You can constrain a pod using labels on other pods running on the node, or other topological domain, instead of just node labels, which allows you to define rules for which pods can be co-located on a node. The affinity feature consists of two types of affinity. Node affinity functions like the node selector field, but is more expressive and allows you to specify soft rules. Inter-pod affinity, anti-affinity allows you to constrain pods against labels on other pods. Node affinity. Node affinity is conceptually similar to node selector, allowing you to constrain which nodes your pod can be scheduled on based on node labels. There are two types of node affinity. Required during scheduling, ignored during execution. The scheduler can't schedule the pod unless the rule is met. This functions like node selector, but with a more expressive syntax. Preferred during scheduling, ignored during execution. The scheduler tries to find a node that meets the rule. If a matching node is not available, the scheduler still schedules the pod. You can specify node affinities using the spec affinity node affinity field in your pod spec. In this example, the following rules apply. The node must have a label with the key topology.kubernetes.io/zone, and the value of that label must be either Antarctica East 1 or Antarctica West 1. The node preferably has a label with the key another node label key and the value another node label value. You can specify a weight between 1 and 100 for each instance of the preferred during scheduling, ignored during execution affinity type. When the scheduler finds nodes that meet all the other scheduling requirements of the pod, the scheduler iterates through every preferred rule that the node satisfies and adds the value of the weight for that expression to a sum. The final sum is added to the score of other priority functions for the node. Nodes with the highest total score are prioritized when the scheduler makes a scheduling decision for the pod.